right, so let's underline like we always do. Underline. See what we got here. It's a tricycle wheel. There's the radius. Okay. And it accelerates at, what's that rad per second squared? It's not acceleration. Well, it is. It's the rotational acceleration we call alpha. Did you remember that? And it does it in a period of this many seconds. What is the angular velocity? Oh, you know what I forgot? It starts at rest where omega equals 0. So what equation has alpha and omega and t? Isn't it alpha equals delta something of a delta something? Exactly. So it's just straightforward analog of acceleration. This is the rotational analog of acceleration. So you'll have stuff like this in tonight's homework. So it's just a little plug-in. So the final velocity is unknown. The initial is known at 0, and the time is 8.6 seconds, that is, and equals 2.3 radians per second squared. We do a little cross multiplying, and we get 20 radians per second. With two significant digits, we'll write it like this: 20 radians per second. So pretty simple stuff. How about you underline the next one? The radius. It starts from rest. It accelerates at this alpha. Now wait a second. It seems like the exact same problem, but it really isn't. It's not really the exact same problem because now yeah. So isn't this? So we can just use what we got from before. From before it was this was 20 radians per second, and so aren't we just converting? How do you go back to the old stuff? What do you do with the new stuff? Right. So this is so simple. Take that 20 and multiply it by r. So 20 times 0.11. So the velocity is 2.2 meters per second because the rotational or angular velocity was 20 radians per second multiplied by r, which is 0.11 meters, and it becomes 2.2 meters per second. Let's look at the third problem. Let's underline again. Potter's wheel, angular, that's the omega. I think this is the lowercase omega. Yeah. Accelerates, there's my alpha. What is the angular velocity? So this is straightforward. There's a t. It's kind of like what we did, already did, right, Gigi? What's that equation? Alpha equals delta. Right. So alpha is squared. Let's see. The change was it started from rest and it went to, so it's 3.2 radians per second minus 0 because it started at 0, and it did that in 6. Oh, I'm sorry. Good catch. So it didn't start at 0, did it? The initial's not known. The initial. Okay, so it's so we got to make it 3.2 radians per second minus the initial, which we don't know. Thank you for that. We cross multiply. And do a good job on your homework. What's that? Yeah, it's graded on a great curve, on a really nice curve.